In this video, we're going to jump right in and get the R19 to R9 BGP and 8 to 14 BGP configured, because they're already running BGP on the VPN side. So we should just be able to do the peering here and advertise a route, say for instance the 10.192 and the like a loopback, and we should be able to get BGP. We should get MPLS to go across if I've done everything correctly. So first thing we're going to do is type in router BGP 65, or no, BGP 65,000. And we'll type in neighbor is going to be 199.0.0.19. Remote AS is going to be 2.20. And we're going to do the same thing on 19. Whoa, I want to do that. Config T, router BGP 2.20. I'm going to say BGP AS dot notation, AS notation dot, and enter. And then we're going to type in neighbor is going to be 199.0.0.9. Remote AS is 65,000. So now we'll form a BGP relationship here momentarily. And just be patient while that comes up. And I'm always anxious when it doesn't come up right away. I don't know why. I just am. Oh, wait a minute. What did I... Oh, Doofenshmirtz. So obviously that's not going to work. If I copy and paste this over to 9, that might work. Router BGP 65,000. Right click and paste. Should work now. Go arrow. No. And then on 9. And 9. Okay, yeah. When it comes to this stuff, this bugs me when it doesn't come up right away. It's gonna be like torture in the lab. But anyway, let's go to 8 and 14 and get that configuration going. So neighbor is gonna be 148.0.0.14. Remote AS is 2.20, and we're going to do on 14 config T router BGP 2.20, and remote AS or neighbor is going to be 148.0.0.8. remote AS is going to be 65,000. Now, the one kicker with this is when you do this on 9, did it ever come up? It never came up. Why did it not come up? Oh, yeah, that's right. Haha. Yeah. So there's a reason why it didn't come up. I'll tell you why. Because I didn't put it in the VRF. So let's just go up here and type in no. All right. So we're gonna type in address family, IPv4 VRF brown. And hit enter. Now we can type it in. So neighbor and 199, or I should be able to right click and paste. Ta-da! And then activate. That should bring it up. I forgot about that. You have to put it in the VRF, because before I was in the global routing table. So I was like, sending hello, sending updates, nothing's happening, and then underneath the VRF, as we wait patiently, please work, pretty please. Alright, so let's see here. Same thing with this guy, we're in the wrong location. So in 8, we have to type in Control-A no, and go address family IPv4 VRF brown, and wata, and, or no, I'm sorry, Control U, copy and paste this bad boy, that, and then activate. So did it ever come up on that? Why is this not working? I'm perplexed. What am I missing? I'm thinking here. I'm not sure what's broke. What didn't I do right? Nothing that I can think of. Thinking, did I not add something that I was supposed to add? No. Everything's right as far as I can tell. So what will end up happening though is 19 and 14, they won't be able to actually send updates to each other. Now why would that be? 8 and 14 and 9 and 19 should form pures, no problem, right? So let's do a debug BGP IPv4 VRF brown. Wait, debug BGP IPv4 unicast keep alives. Let's see if it's even seeing anything. So let's do a ping to VR. Oh, what was that? So we're going to type in ping VRF brown 199.0.0.19. Ah, so we have an issue between here and here now. Alright, so it's not that. We're going to go over to 19 and we're going to drop out of here and do a ping to 199.0.0.9. Alright, so we have nothing's going to happen if you can't ping. So it's going to, well, that should have been the first thing I tried. So let's go to 8 and 14 first. Oh, there it goes. It just took a while. So now, if we drop out here and do a show BGP IPv4 unicast for IPv4 or show BGP VRF brown IPv or all. Show IP BGP? No, show BGP VRF star all. Oh, that's right, he's not advertising anything. So show IP BGP summary. So we have that. So show BGP. Show BGP VRF brown. Okay, so what I need to do on this, so let's go check 9 and 19. You all here. And show run interface gig 1.199. So let's do a ping to, let's make sure that router 19 is show run interface gig 1.199. Alright, so they have the same broadcast domain, same VLAN. So, alright, so let's go to 14. And we're going to type in, let's actually do this. Let's do a exit out of here and type in interface loopback. We're going to say 150. Type in IP address is going to be 10.1 14.150.14 and a 24-bit mask. Router BGP 2.20. I type in network is going to be 10.1.14.150.0 with a mask of 24 bits. And then we go to router 8. There we go. So we're receiving that route in now. So that should be that. So now we go to 9, and we do a show BGP VRF brown. We're receiving that route in. So it's telling us where it's coming from. So that's good. That shows us that we're getting that in and everything else is working. So now, notice how the path though, it shows up as that. So 131092, same thing over here. So if I was to go to router BGP 65000 and type in BGP AS dot notation dot and do the same thing, now it'll show up as 2.20. So it'll show up differently now. So that's that. Now I'm gonna have to come back to the 9 and 19 thing because I'm not sure why that's not coming up. Show IP route. So what we're gonna do is I'm gonna come back to that in a few minutes, and I'm gonna focus on getting these guys operational. So we're gonna have to do redistribution and stuff like that. That's where So where we're gonna focus now is on, we're gonna start with router 6. So I'm gonna bring this bad boy up here, and we're gonna go on router 6, and what we're gonna do is we're gonna go to global config, and we're gonna type in router BGP 65000, and what we're gonna type is address family VPNv4 unicast. No, that's not it. No, why do I have a feeling I'm in the wrong location? VPNv4 unicast. No, that's not it. No. Where do I gotta go? I gotta go to something to pull something out. No, I need to be able to redistribute OSPF and BGP. So how do I do that? Oh, maybe I'm supposed to type in router BGP 65000. No, 65,000. Or hold on. Let's exit out of here. Router BGP. No, that's not it. Let's see here. Address family. IPv4. VRF. That's where it is. I was like, where the heck is it? Red. And then we're going to redistribute. There we go. OSPF 1. VRF specified does not match this router. Do show run VRF. Begging your pardon. VRF red is right der. Hold on a minute. Where's VRF red? Did I not? Just family IPv4 red. Redistribute OSPF 1 VRF red. Is that right? I remember having to do that. I remember having to do that. Router OSPF 1, and we're gonna redistribute. Is there an end? Yeah. No, hold on. I'm confused. This is the one part of it that always catches me up. Address family. I don't think I have to go into IPv4. Oh, no. Address family. No, hold on. exit out of here, router OSPF1 VRF red. You know, I never got the VRF configured, or did the OSPF configuration. That's why. So if I was to do a do show run pipe section OSPF, that's why we're having a hard problem. Because I still got this configuration sitting. Did I actually apply the do show run interface gig 1.46? Yeah. Let's ping VRF red 46.0.0.4. Yeah. Why is that not working? I'm confused. Oh! Duh. Different process number. FigT router OSPF 2 VRF red. That'll work. I'm like, what? What is going on here? I was like about ready to pull my headphones off and go, I'm giving up right now. I give up way too easy. We're going to type in redistribute BGP 65,000 and it's subnets. Okay, so that's going to get us that. Now, if we were to go to router 7 and do the exact same thing, so now we're going to do this. We're going to do a show run pipe section BGP and OSPF, and I'm just going to bring this down because there's going to be a lot to go through. So actually, the only thing we need to really focus on is right up here, and we're going to say focus right here on where is it? We're going to pull, where is our fancy notepad doc? There we go. So we're going to go whack this. We're going to copy, oh, there's more information up here. So we're going to pull, oh, that was it. So we're going to pull router OSPF 2 VRF redistribute BGP 65,000 subnets. Going to do that. And then we're also going to look at, what the heck? Show run BGP. Show run section BGP. Why am I having a hard time finding it? Did I not just do this? Config router BGP 65,000. Address family IPv4 VRF red. Redistribute OSPF. Oh, redistribute 2. That's why. Show run pipe section BGP. That's better. Alright, so now I'll be able to go on to 7 and do this. And if you put a exclamation point in here, it typically tends to bode well. Bode better, I should say. So now we're going to be able to go to, let's see if this is actually going to work. Let's go to router 5. And we, actually, one step, I'm getting ahead of myself here. We actually have to go, let me bring this over here. There's no good place to put this thing. On router 7, on the connection to router 5, we actually have to go to show run interface gig 1.57. Alright, so the configuration's there, so we have to type in router OSPF 2. We're going to type in network is going to be 0.0.0.255 area 0. And we have to do the exact same thing on router 5. So show run pipe section OSPF, and that's what I thought. So config T router OSPF 2. Now the process number is locally significant, so it doesn't matter what you actually use. Type in network 57.0.0.0 0.0.0.255 area 0. So we should form a neighbor relationship here momentarily. Or you know what? No, we're not. I apologize. That's my fault. Control A, no. And type in router OSPF 2 VRF red. And then the network statement. That's my fault. And the network statement should come up here momentarily. So if we jump out here and type in ping VRF red 57.0.0.5, we get a ping. Same thing on router 5. Show IP interface brief. Ping 57.0.0.7. We get that. And again, I'm extremely impatient when it comes to this type of stuff. So while I'm waiting for that, let's take a look at 6 and do show IP OSPF neighbors. And I don't have the connection to router 4 set up yet. So config T router OSPF 2 VRF red network 46.0.0.0 0.0.0.255 area 0, and then we're going to go to 4. Oh, beautiful. There it goes. So 7. Ha ha! It worked. So now on 5, if I jumped out, Rumpelstiltskin. Show IP route, we're going to get some routes here. 1014. So that's a good sign. So we're getting the 1014.150 from router 6, which if we do a trace route to this guy, .14. Well, that's actually taking a while. Now mind, this is a CE device. So 46.0, so that's inherently slow. So it's hitting the MPLS, and it's going to go hit 7. Then it should hit pop the label. We're on router 8, so it's going to. So, and I'll break this down real quick for you guys. And momentarily, we're at 14. So now what's happening here is we are IP routed to router 6, which is this router 6 address, and then we are encapsulated router MPLS. So this guy right here is the VPN label. So this is the actual label that's associated for the route. So the 10.14.150.14, and then this 20 here is the transport label. So this is telling when router 6 receives that, he's going to do a lookup inside of the MPLS fib and say, what route or what PE router do I forward this label to based on its transport label. The transport label is going to be the outer label pointing to the actual PE router, and then he goes, when 7 gets it, he does a PHP or penultimate hop pop, so he pulls the VPN label off, and so it's no longer being MPLS routed, it's being IP forwarded down to 8, which is going to be the PE router, and then he drops it down via IP to router 14. So that's a good sign. So that means things are working. So now we're going to do on 5, we're going to go to 5, and thankfully now it's clear. So actually what I'm going to do is I'm going to go to global config, and I'm going to show IP interface brief, and I'm going to create an interface loopback 100. Type in IP address is going to be we're going to type in 10.5.100.5 24-bit mask, and then we're going to type in router OSPF 2. And we're going to type in network is going to be 10.5.100.0 0.0.0.255 area 0. Now we go over to 4 and we do a show IP route as soon as the route propagates. And you'll know when it does propagate because it'll show up as a 10.5 as an OSPF inter-area route. So 7 should see it. So show IP route VRF red. So he's got the route here as an OSPF route. Let's go to 6 and jump out here and do a show IP route VRF red. He does not have that route. So it's a connection between 7 and 6 that's broke. So I'm just trying to think here. What am I missing? This to me seems like a... let's do a clear IP route VRF red star. Yeah, he's not receiving it. So 7 is sending 7 is receiving it from 5, but 7 is not show IP route. It wouldn't be in here. Let's on 7. Let's do a show MPLS forwarding. And do I have a route for it? 10 dot. No, I don't have a route. And I shouldn't have. Let's see here. 10.1. Six. Show MPLS forwarding. Four. Yeah, he's not receiving it. And so what am I missing here? I want to say it's a route target import export. Let's see, hold on. Let's see. 5 has show IP route. 5 sees nothing. 5 doesn't get anything. So we have some issues with our BGP connector, or we have some issues with our MPLS network. So let's see here. So we have some troubleshooting to do. So the first thing we have to look at is why it's broke. So we advertise a route from 5 to 7, and 7 sees it. 7 sees it right here. Right, we're getting this route in from router 7. So that's a good sign. Now, when we advertise it, let's go to 6 and see if we're actually receiving show BGP VPNv4 unicast all. See, there should be some routes in here, but it's not showing up. So is it a redistribution issue? We're not redistributing it in? And notice how we have the two VRFs too. We have VRF blue and VRF red. So let's see here. We're learning the inter-area route, or the IBGP route from router 8, which we see that. There's a question, that odd numbered path. Oh, this guy right here? Yeah, that's just because of the fact that I don't have I didn't type in the BGP AS notation dot yet, so it doesn't know how to read the it's taking the 2.20 and it's basically just coming up with some random value for it. That's why that's coming in. And let's see here. So let's go to 7 and do a show run pipe section OSPF and BGP. because I have a feeling it might be a redistribution issue. That could definitely be the case. Or it could be this, because we're doing the redistribution. I think it's a redistribution issue, to be honest with you. Let's go to global config. Router BGP 65,000. Address family IPv4 VRF red. Redistribute OSPF 2. And let's go to 6. There it is. Did that pop in? Yes, it did. It popped in. So 4 should have it now. And it does. So that was the problem. I wasn't redistributing. So now, notice how it says inter-area route? That's a good sign. Because what's actually happening is this is considered to be the OSPF super backbone, or what they refer to as the MPLS super backbone. So, because we're running OSPF area 0 here, this guy's running area 0. So basically what ends up happening here is we're running area 0 here, we're running area 0 here. Because of that, this is like an extension, if you will. So, this guy is acting as an ABR, this guy is acting as just a normal intra-area route. So this right here is an intra-area connection, this right here is an intra-area connection, and this right here is an intra-area connection. But because of the fact that 5 and 4 are disparately connected between two PE routers, that's why we're having this issue. So what we could actually do, what would fix this, and we're not going to do this in this video, this is more of an optimization when we get farther down the line, is if there was a task and it said for OSPF PE to CE routing, where it said ensure that the OSPF routes from 4 to 5 and from 5 to 4 show up in each other's routing tables on the CE side as intra-area, which means O routes, we would have to configure a sham link between 6 and 7, which is really, really easy. You just have to create the sham link and know how to peer it. It's really easy to do. I'm not going to do it right now, but that's one of the capabilities that's out there if you wanted to do it. So that's why that route wasn't working. So, and the 57 network is in here now. Now, if we didn't want to have that happen, so for instance, if we, let's say for instance, we didn't want to advertise the 57 network in here, we could create this as a passive interface and it wouldn't peer. So that's one option we could do, or we could just use a distribute list and pull that out of there. But you know, it is what it is. So at least that route is coming over here. So now on router 4, let's do the same thing. So we're going to go to config T, we'll type in interface loopback 100, type in IP address is going to be 10.4.100.4 and a 24-bit mask. And we'll type in router OSPF 1, and we'll do show IP protocols. And we'll type in network is going to be 10.4.100.0.0.0.255 area 0. If we go to 5, okay, so now we have the same problem. We're not redistributing from 6 in. So if we look at here, we have the route here, we have the route here. But the problem is we look at 7, and we do, what was that command we were looking at? Show BGP, yeah. We're getting the route, but if we look at 5, the route's not coming in. So if we go to 6 and show run pipe section BGP OSPF. Redistribute OSPF 2. Redistribute BGP. Okay, so that's working. Could it just be taking a couple minutes? Clear IP route star. Yeah, it's not coming in. So let's go to 7 and see what's up with this. Let's do a show IP route VRF red. Coming as in a BGP table. What is 6C? Show IP route VRF red. Okay, so that does make sense. So we're exchanging that correctly. And we need to... Why is it not coming in then? 4 advertised it. We have 5's route there. The 5's doesn't see it. I'm not sure. Let's do a clear BGP VPNv4 unicast star. Bounce the neighbor, bring the neighbor back up. Wait for it to reappear again. Yeah, I don't think it's a route target issue, because we are obviously had routes going back and forth with each other. It would be not exactly sure what the problem is, because we're redistributing, which is a good sign, and we're redistributing everything. Alright, so we have the route on R7. So path selection is still working. So it sees the route from 6. Alright, so it did path selection, so let's go to 5. Still not there. So let's do this. Let's go to 7, and we're going to do a debug. Debug IP OSPF packet. Let's see what's going on here. That's not telling me anything. Debug IP OSPF hello. That's not telling me anything either. So 6 has got the route. 6 gets the route from 4. Seven gets the route from 6. So can I ping trace route to 10.4.100.4? Nope, sure can't. Trace route. It wouldn't be VRF, because VRFs only point down to the customer. So why is it not working? What am I missing? What am I missing here? So we advertise OSPF to BGP. BGP to BGP, BGP to OSPF. 7's learning the route, right? Show IP route VRF red. We have the route via BGP. Learning it via router 6. Show IP OSPF database. We don't have the route in the database. I'm actually a little. I'm actually kind of stuck here. I'm not sure what the problem is. So you know what? Let's not get stuck on one particular issue, because that's what's going to hang us up in the lab as we sit there and put all of our blood, sweat, and tears into one particular issue. We'll come back to that in an upcoming video. I'll do a troubleshooting, and we'll troubleshoot it until we figure it out. What we're going to do is I'm going to do this rip route here and on 6. So I'm going to go to global config. I'm going to type in router rip, enter version 2, no auto, and then I'm going to type in address family, IPv4, VRF blue, and then I'm going to type in network is 65.0.0.0, and do the same thing on router 5. You know, I think it might be something to do with R5 to 7, because I'm not seeing any OSPF routes. But anyway, router rip, version 2, no auto, network is 65.0.0.0, and let's see here, show IP route rip. That makes sense. So what we're going to do is we're going to go and create a interface loop 200. IP address is 10.5. We'll say is 172.16.5.5 24-bit mask. We're going to go to route-map and type route-map rip, and we're going to type in match interface loop 200 router rip, and we're going to type in redistribute connected route-map rip. And we're going to jump out of here to a show IP route. So we have this network right here is being advertised. Let's go to 6 and do a show IP route VRF red, or I'm sorry, green, blue. There's the rip route. We're learning that in here. So now we have to go router rip, address family IPv4 VRF blue, redistribute BGP 65,000 with a metric. And the metric can either be a specific value or transparent. If you use a metric, you can specify it, or you can use transparent, which is going to copy whatever is advertised from RIP, and it's going to copy that into the med value of BGP. So we're just going to use transparent. And then we're going to go to router BGP 65,000. and address family IPv4 VRF blue, and we're going to redistribute RIP and give it a metric of, or actually we don't even have to do that, redistribute RIP. So that's all we have to do. So now if we were to go to router 5 and show IP route, we should have a bunch of RIP routes in there now. And ironically, there's our route. It's being advertised by RIP. So I think we have a problem with 7 and 5. So show IP OSPF neighbors. Show IP OSPF 2 interfaces. Interface brief. Gig 1.57. Show IP route OSPF 2. Show IP route VRF red OSPF 2. Alright, so we have that route there. So if we were, see, that's the part that aggravates me. It's not taking that route. It's not redistributing it from BGP. So show run pipe section OSPF. Oh! I got the... What did I do? I goofed it up. That's what the problem is. Right here, we have redistributed OSPF 2. But we don't have BGP. So, router OSPF 2 VRF red. Redistribute BGP 65,000 subnets. So now we should go to 5 and we should have... There we go. That was the problem. Again, it's one of those things where if you don't set it up just right, you can have it blow up in your face. So that's my fault. So making sure you redistribute correctly, that's how that's going to work. So like I said, it was a redistribution issue. Notice how all the RIP routes went away because there's a better administrative distance on OSPF. So we have that. So now to finish up this video, we're going to jump over and get the configuration for EIGRP running. Now, with EIGRP, it's not a different process, it's a different autonomous system number. So, we're going to focus on that now. So, we're going to do 11. We're going to type exit out of here. We're going to type in router EIGRP 1, and we're going to hit enter. We're going to type in address family IPv4 VRF green. And we're going to type in network is going to be 10.1.112.0, 0.0.0.255. And that will hopefully get us operational. Let's go to 12. Oh, wrong autonomous system number. Router EIGRP 1013. Address family IPv4 VRF green. Okay, why is it not coming up? Again, I'm impatiently, I'm very impatient when this stuff happens. So, let's see, what am I missing here? First I want the I want the PE to CE come up, then I can redistribute it between BGP and EIGRP. Let's do a ping VRF green 10.1.112.12. Okay, that works. Let's see why. Show run interface gig 1.112. Encapsulation 112. Show run interface gig 1.112. Encapsulation 112. So we know that's working. So we know we have layer 3. So let's do a debug EIGRP packets. Let's see what's going on here. And it's not that I don't have any authentication going here, so sending hello but not receiving a hello. See that? If we were receiving a hello, I'd be a little happier, but we're not. So you all, and we're going to do a show IP EIGRP interfaces. Bring this out just a little bit so you guys can see this. And then we're also type in neighbors. We have no neighbor, which is a bad deal. So the same thing on 11. We're going to do show IP EIGRP neighbors, show IP EIGRP interfaces. Okay, show IP EIGRP or VRF red or green neighbor interfaces. So we're going to go to show run pipe section EIGRP. Why do I have a feeling I'm doing this? Hold on a second. Let me do router EIGRP 1013. No, and pull this off. I didn't notice that. From here, we're going to do a ping VRF green to 224.00.10. We got a response. So that means EIGRP is working. So if we can ping the multicast address, then and we get a response from router 12, that's a good sign. That means multicast is working, so should EIGRP. So, there's something that I'm missing here. I'm sure of it. Let us pull up. Let's pull up our notes real quick, and we're gonna do file, open, and from Cisco stuff we're gonna type in EIGRP txt open, and so we're gonna do near the top here. We're gonna do it's down at the bottom. No, that's all IPv6 crap. VRF. Haha. Okay. 44 hits. Find next. Oh. VRF. Find next. Alright, so you're supposed to do EIGRP, autonomous system number, address family MPLS, VRF, autonomous system. That's what I forgot to do. Like I said, there was something I knew I was forgetting to do something. Router EIGRP 1013 and an address family IPv4 VRF green, and autonomous system we'll type in 112. And we'll type in, from here, we'll type in the network statement 10.1.112.0, 0.0.0.255. Exit out of here, and then we're going to type in the old address family config that we had in there before. No, and pull this out. Now what we're going to do, and we're going to go on 12 and do the same thing. Go to global config, no router EIGRP 1013, router EIGRP 112, network of 10.1.112.0, 0.0.0.255. But see, that's still not convinced that that's the problem. So that's why we go back to our notes. MPLS and okay. On the CE, so this is going to be create the CE, create the EIGRP address. So with named mode, the autonomous system mode, router EIGRP1, address family IP, okay, network, redistribute, wait, no. So we've done this. Alright, so we did that, and we're still not pulling up a network. Show IP, EIGRP, VRF, green. Neighbors. Yeah, see, we're not forming anything. Show run interface, or show IP interface brief. Show run interface gig 1.112. He's in that connection. He's there. Ping VRF green 10.1.112.12. And we can ping it. That's the frustrating part. We can ping it. We can ping it and debug EIGRP packets. This guy's not sending any hellos, but I bet you 12 is 12 sending any hellos. Debug EIGRP packet. If he's sending hellos, but 11 is not. Yeah, see, he's not sending any. 12 is sending hellos, 11 is not. So let me go on 11 and let me go type in interface gig 1, and let me just do a quick shut. That's going to take everything down. BGP, LDP, OSPF, EIGRP, if it was running, take everything down. So I'm going to do that. I'm going to type in no shut to bring everything back up. It'll take a couple of minutes for that to happen. So this is the logical troubleshooting that I'm going through. Okay, what steps do I need to do? Am I going about this the right way? And this is why you need to go through and make sure you do this stuff, because if you're going through and it's the little things like the additional autonomous system keyword that I was missing that should fix this problem, and I'm like, oh, forgot about that. And so by reiterating and doing all this stuff, is a big deal. So LDP is up. I didn't see BGP come up yet. And it probably hasn't yet. Yeah, see, I'm not sending any hellos. That's what the problem is. This guy's not sending hellos. So let's go to 11. It could be a thing with the router too. Let's do show IP protocols. And for EIGRP 1013 and for that could be the problem though. Show run pipe section EIGRP. Let's do this. Let's try to go in here and type in no router EIGRP 1013, and then we're going to do a router EIGRP 112, and then address family IPv4 VRF green, autonomous system 112, and then network 10.0 or 10.1.112.0.0.0.255. Aha! Guess what? That's what did it. That's a good sign. So I'm going to do a show IP EIGRP for VRF green neighbor. There it goes. So now we have the connection. So now let's go over to 10 and 13. So we're going to take a little over an hour to get this one done, obviously. So we have that done. So we're going to type in you all here, and on 12 the same thing, you all. So now what we're going to do is on 11 first. Let's get this operational. So go to global config. We're type in router BGP 65000. We're type in address family IPv4 VRF green, and hit enter. And we're going to type in redistribute EIGRP 112, and then we're going to say the metric is, we're bringing EIGRP into BGP, so we don't actually have to set a metric. We're going to type in router EIGRP 112, type in address family IPv4 VRF green, and we're going to say autonomous system 112, and we're going to type in redistribute BGP 65000, and we're going to have to give it a metric of, we'll say something 155, 1, and 1500. And we should be able to get on 12 show IP route. We're getting a bunch of routes in. So this means MPLS is working the way it should be. This is a good sign. So now we're going to go to 10, and we're going to exit out of here, and we're going to type in router EIGRP, or let's type in no router EIGRP 1013. Okay, and then we're typing router EIGRP 112, address family IPv4 VRF green, autonomous system 112, network is going to be 10.1.103.0, and then we're going to go over to 13 and do the exact same thing. So show IP protocols, config T, no router EIGRP 1013, and router EIGRP 112, network is 10.1.103.0, show IP EIGRP neighbors, interfaces, ping 10.1.10.1.103.10. Alright, this is definitely a local issue. So let's do a ping 224.0.0.10. If I can ping, okay, I didn't get anything back. So I think I'm not sure if it's 10 or 13 is the issue, but let's go to 10 and go to interface gig 1 and shut it down. You're not going to lose anything because of the fact that nothing's actually operational yet. So the line protocol goes down. Then we type in no shut to bounce the interface. See if that helps anything. Okay, let's back up. I'm not anticipating that's going to fix it, but you never know. So okay, it's back up now. We're actually going to do a debug EIGRP packet. So I'm expecting him to start sending hellos, and he is. He's sending a hello. Okay, and now 10. I should be able to go to end out here and do a debug EIGRP packet. This is one of the quickest ways for me to determine if it's an EIGRP issue or something else. Alright, so he's sending hellos, nothing's responding. So I know I have it configured right because I was able to figure it out on the connection between 11 and 12. So at this point in time, I think it's the connection between them. So you all, and type in config t interface gig 1.103 and shut the interface down. We'll just take it down for a minute, and then we'll do a no shut. Now I know specific pieces of this work. I know the main interface works. I have other sub interfaces. So if I was to type in do show IP route, I have active OSPF adjacencies and all this other stuff. So I'm thinking it might be just the sub interface. Do show IP interface brief. 103 is there. Let's do a show run interface gig 1.103. Okay, we have 10.1.103.10, and you all here show run interface gig 1.103 here, 10.1.103.13. Platform ring receive and transmit. What is that? Show CDP neighbors. I'm not sure what's up with that. Unless there's another 103 on here that I'm not seeing. No, I don't see any 103s. Let's try to do a connection between 12 and 13. See if that'll come up. So let's go here. We'll type in do show run interface gig 1.103. Type in interface gig 1.123. But we have to be careful because we're using 123 here. So that makes me wonder if we're using 103 somewhere else. I don't think we are. We're using 116 there. So that's one of the things you have to be careful when you're doing a lot of sub interfaces like this. Make sure you don't have overlapping subnets. We'll type that in, but we're going to type in encapsulation.1q is going to be 231. and we're just going to copy and paste this information in right here. So we're just going to, where's our trusted notepad doc? So we're going to get rid of that. We're going to bring this over. And there's a question, why am I doing this? Just to test to see if it's the interface or not. Because if it's, this is just my way of doing that. So we're going to type in 123. We can't do that. I'll do 132. And 132. 131. 2. And so that'll be what we do there. And just copy and paste that in like so. And right click and paste. And then we're going to be able to do the same thing on the remote end. We'll do a home, and in cap.1q 231, and then we're going to do, this got to be 12, this will be 12, and this will be 12. Go to router 12, config t, interface gig 1.123, and then right click and paste it in, and we should be good to go. So now what we're going to do is we're going to do a do ping 10.1.132.13. Well, since we know we have a new router up and nothing's happening, I think it might be time for a reload on 13. I think 13 is our problem, because we're not able to form any peers on that. Let's do from the remote end. Let's do a do ping 10.1.132.12. Yeah, I think 13 is the problem, because we have a neighbor relationship with 12 and 11. I think 13 is our problem. I think that just the router needs to be rebooted. So what I'm going to do is, nice thing about these, I don't know if you guys knew this or not, but if you type in dir, down here at the bottom, I actually have a couple of config files set up. So whenever I reload these routers, it loads up to like it was a brand new router. And I have a couple of base config set up, so I have pre-IP addressing. So this is like if I'm in the middle of something and I want to lap something up on the fly, I can set up pre-IP addressing, which basically sets it up to as a brand new router. I have the IP addressing, which is set up to the configuration prior to me actually starting this, and then the lab. So the lab is the config I have running right now. So I'm going to reload this box and go from there. See, now what I actually can do is, if I was to go in here and let's do this real quick and type in more flash and grab this guy, it'll show me what it's actually got configured. So it's got 139. What has it got? 139. Oh, this was something else that I was working on. Yeah, see, this is different configuration. So actually, I can get rid of that one. But if I do more flash, I do pre.ip.addressing .cfg. Okay. Well, let's do lab. What it shows me here is I have all of the base setups for everything that I've got configured here. So that's pretty much what's going on here, and I'm just going to go ahead and reload this box. And nope, don't modify anything, and I can just bring it right back up because I didn't really do a whole lot with this router. So I'm going to reboot that guy. So as you can see, we have connectivity here. So now the next thing we're going to do, and I apologize about this taking so long to get operational, but it's one of those things where when you're working on stuff, you need to, I think it's a reload. So the other one I was having a problem with was 9. And 9, show IP, interface brief. Let's do a show IP route VRF brown. So what is 19 learning? Show IP BGP. Show IP BGP summary. So yeah, see, the connection never came up. So I know 9's working, 19 is having an issue. So at this point in time, it would be, okay, let's go ahead and reload the router. So what we're actually going to do is, as I've tested this a little bit, let's do a show run interface gig 1.199. We have that encapsulation here. Let's make sure 9 is on the same page. Show run interface gig 1.199. Encapsulation.1q VRF forwarding. Show run pipe section BGP. And we have that set up there. You know what? Now that I'm sitting here thinking about this, hold on a second. Router BGP 65,000. Neighbor 199.0.0.19. Remote AS is 2.20. That's what I thought. So 13's back up. Good sign, good sign. So we're going to go to config, replace, and we're going to say flash. We're going to say lab.cfg. Yep. Oh. Cool. So that replaced it. Show IP interface brief. We're going to ping 10.1.103.10. Taha! Success. So config T, router EIGRP 112, network of 10.1.103.10, or 0. 0.0.0.255. Boom! Got that problem fixed. So now, if we were to do this and network of 10.1.132.0, 0.0.0.255, go to 12 and do the same thing. So router EIGRP 112. Network 10.1.132.0, 0.0.0.255. Oh, you know what? I gotta put that configuration back on there. That's why that's not working. Do show run interface gig 1.123. And we're just gonna. That's interesting. Why is there 2 in there? Pull that out of here. I don't want to confuse anything. and we're just gonna take our config that we had here, and we're just gonna flip it around to make it on 13 again. Whoa. Oh. Boom. Okay, that takes care of that problem. So now if we were to do a show IP route, what the? It's good stuff, man. It's good stuff. So now we have full reachability, minus 19. So let's go ahead and just reload 19 real quick. Reload, and nope, don't save anything. Confirm, and that should take care of that. I did a massive reload about 5 hours ago, and this is the fallout from that. So things don't always work as they're intended. So I'll pause the video. I'll get BGP running as soon as it comes back up, and we should be able to get routes to propagate and things like that. So now the thing with this is with router 13, you notice he's learning everything from router 123. So if I did a trace route to router 4, well, let's actually go to 14. Let's go to 14. So that 14 route is right here. I'm learning everything from, let's do a trace to, I'm going to learn that from router 12. So this is where that EIGRP site of origin thing comes into play that I was telling you about earlier. That is where this comes into play. So we're going to hit router 12 in a moment. Yep, and then we're going to work our way through the MPLS network. So we should go 11, 10, 9, or 11, 8. I'm not sure yet. 11. It might have to go 11, 10, and then 8. Yeah, 11, 10, then 8. That's the shortest path. Then 8, then down to the that guy. So now, because we're not doing R10 redistribution, so we'll do that real quick while we're sitting here waiting for that. So it's MPLS being MPLS routed, which is a great sign. So now we're going to jump on to router 10, and we're going to say router EIGRP 112 address family IPv4 VRF green autonomous system 112 redistribute BGP 65,000 into EIGRP. We have to set a metric of, we're going to say 1500 and 1 and 255 and 1 and 1500, and then we're going to type in router BGP 65,000. We'll type in address family IPv4 VRF green, enter, and we're going to type in redistribute EIGRP 112, enter. So now 13, when we go to him, show IP route, they should be coming right from, we should be getting a mix of these guys and these guys, because they're equal cost routes. Well, some of them are. So that 14 route that we just trace routed to, we're still learning that from router 12, which is fine. But you'll see that we usually will have, in some cases, equal cost routes depending on where they're at. And 19 is up. Enable, we'll do a dir, and there's that lab config, so we'll do a config replace flash. It's going to be lab.cfg. Yep. We're going to go to global config, router, BGP 2.20, network or neighbor is going to be 199. That's 0.0.9. Remote AS is 65,000. Get router 9. I'm like expecting things to come up like now. Show IP-BGP summary. Debug BGP IPv4 unicast. Everything. I want to see everything. Alright, so it's actually sending and receiving BGP updates. So what we have is a failure here. So let's go to debug this guy. So there, it's actually sending. So let's do a UAll here, or do a show host, show hosts. Oh, it's not all. Ah, brother. So let me ping 199.0.0.9. Uh-oh. It's a bad sign. Hello, Tokyo. Yep, see, we have a problem with the encapsulation now. So it might be Router 9's problem now. So, alright, well, I'm an hour and a half into this video, and we've gotten most of it operational. So this is actually, I was commenting to a friend, and he said that this happened to him in the CCIE lab, where he was doing RIP configuration, and it actually just bugged out on him, or he had to reload the router, and it fixed it. So, but anyway, that's the situation that I have at hand. Sometimes these connections don't always work, so just going based on what I'm seeing here. That's all. Actually, let's do a debug BGP IPv or VRF brown IPv4 unicast all unhandled major event code 128. What does that mean? That is the very first time I've ever seen that. So let's I'm actually on my other monitor. I'm going to pull up a Google window and pull this guy over. So we're going to say, what is that error? Unhandled major event code. BGP router. Unhandled major event code. What does that mean? Yes. What is up with that? Paul Stewart. Huh. I think that's CCIE Paul Stewart on CLN. Tried to turn up a multi-IP BGP session, not coming up. Did a debug with the neighbor IP and got this. As far as I've been able to find out, this message is completely harmless. Huh. Yeah, I'm not sure what's up with that. Unhandled major event code 128. Minor 0. Do we have an update? Customer's link could be saturated, causing issues for BGP. Yeah. So you all for this like crushes my CPU. Alright, so that seems like it has slowed it down. Alright, so what is up with this? What did he debug? Oh, what did that say? right there. It says active open failed. Update source null is not available. So in other words, it can't ping it. So ping VRF brown 199.0.0.19. Yeah, that's what I thought. Yeah. So anyway, that's what's up. I'm gonna let this one sit for the night. But as you can see, there's a lot to it when you actually get going. These are the videos I like doing because they make you you discover the most. So I hope this has been informative for you, and I'd like to thank you for viewing.